From on block day, there are 4 types of transformations that we can do. And yes, you're correct. They are vertical translations, which basically means moving the graph all the way up or all the way down. All right. There are phase shifts. Phase shifts, which means a fancy word for saying right and left. There's amplitude, which is defined as the distance from the center of your trig function, your graph, to the top or the bottom. That distance, it's an absolute value. And then your fourth one is period. And that one is the hardest one to get. So we're going to spend today focusing on just amplitude and just period. And then tomorrow we'll put them all together and graph them, okay? So here we go. If you take a look at that handout I gave you, when you have say y equals a times the cosine of x, whatever is being multiplied by in front of your trig function, whether it be sine or cosine, for sine or cosine, whatever that a part is, the absolute value of a is going to be your amplitude. The absolute value of a is going to be your amplitude. Okay? And whatever is being multiplied in front of the x, or in between the trig function itself and the x, is going to be the period, but it's not exactly what you think it is, right? Now, because the sine and the cosine have a period of what? Anybody know? Excuse me. No. What is this? What is the period for sine and cosine? How long does it take to complete one full cycle? 2 pi. So we take 2 pi and we divide it by whatever number is in between the trig function and the variable. Yeah, the w part. Yeah, you got it. Yeah, the w part. Okay, so on our little example here, I have a couple of them for you. What is the amplitude of this graph, 3 cosine x? Yeah, the amplitude is the absolute value of 3, so that gives us 3. What's our period? Yeah, it's 2 pi divided by 1, since there's a 1 right in front of the x. So 2 pi divided by 1 is just 2 pi. So the period is 2 pi, the amplitude is 3. That one's pretty easy. That's a little the warm-up, okay? All right, let's go to B. What's negative sine half x? There's 2 things going on here. What does the negative sign do? That's going to give us a reflection over the x-axis. Good. Reflect over the x-axis, correct? And so the amplitude has to be the absolute value of negative 1, which of course is just 1. All right? What does the 1/2 part do? It's used to it's used to figure out what the period is. So I take 2 pi and I divide it by a half. And that equals 2 pi times 2, so that gives me 4 pi. So the period is equal to 4 pi, which means that it takes twice as long to complete one full cycle. Usually a full cycle is just 2 pi. All right, let's try this one down here. How about y equals negative 3 cosine of 3x? A couple of things going on, right? What is the negative going to do? That's going to give us a reflection, right? We're going to have a reflection over the x-axis, true. We're going to have the amplitude, has to be the absolute value of negative 3, which is 3.
What does the amplitude mean?
The amplitude is that distance, so kind of like this, the distance from the center line to the top or the center line to the bottom, that distance. And the period has to be 2 pi divided by the number that's in front, so that gives me a period of 2 pi over 3. So it takes a distance of 2 pi over 3 to complete one full cycle, which is much less than 2 pi, right? Okay, you guys catch on to this so far? All right, good. All right, let's try this one. 4/3 times the sine of 2/3 x. What is our amplitude going to be? Absolute value of 4/3, right? What's our period going to be? 2 pi divided by 2/3, which is how much? 3 pi, you got it. Nice job. 3 pi. Okay, I'd like to show you something from this. Is it this one? Yeah, this is the one. Okay, no, this one. All right. So what I have there is I have a regular old sine curve that's graphed in red. I'll move this back down to 2 pi. Okay. So here's my sine curve, right? Goes up, goes down, comes back, and then around. What is the sine of negative x going to do? Predict what the graph's going to do. What's the sine of negative x going to be? Anybody have any thoughts on that one?
Reflected over the y.
Reflected over the y. Let's see here. If I show this one. Okay. Is that reflected over the y?
Yeah.
No, it's reflected over the x, right?
Oh, the x.
So this negative sign inside where the amplitude is can be pulled through, and it's the same thing as putting it on the outside. Negative sign of x. So that negative sign can be pulled through the entire trig function, right? So my next question is, what happens if I have two negative signs here? What if I have a negative sign on the inside where the amplitude is, and a negative sign on the outside, or sorry, where the period is and where the amplitude is? What do you think that's going to do? That's going to be a normal one. So if I do my green graph here, it should look exactly like what? The red one. So here we go. Let's show, and check it out. It just covers the red one up. All right. So that being the case, can you guys then on your own figure out the amplitude and the period for 9/5 cosine negative? Here we go. Let's go back to our game here. All right. Let's do the easy part first. What is the amplitude of this thing? Yeah, the amplitude is just the absolute value of 9/5, which is just 9/5. Okay, good. Now for the period, I'm betting that most of you did 2 pi divided by negative 3 pi halves. Yeah? It's fine. Okay, and what happens when you divide a fraction by a fraction? You multiply by the reciprocal, so that's 2 pi over 1 times a negative 2 over 3 pi. So the pi's, of course, cancel. That leaves us with negative 4/3. But it turns out the period, if you check the answer in the book, they will give you just a positive 4/3 distance, because we're talking about a distance, so leave your answer as positive 4/3. Okay? Fair enough? Sound good? Okay, great. Now, take out your graphing calculators if you don't have those out already. And what we're going to do now is we're going to go take a look at the graph and then try and figure out an equation that could match that particular graph. And these are going to be hard to draw. So if you just want to make a quick sketch, that's fine. Or if you just want to sort of pay attention right now and get the notes later, that's fine too. But there is definitely some strategy going on here, and that's the part I want to get across to you. All right? So the direction is going to be something like this. Find an equation for this trig function, okay? The first choice you have to make is whether or not you're dealing with a sine curve or a cosine curve. And the answer is it could be both. But one of them is always easier to deal with than the other. And the reason it could be both is because if I have the graph of y equals the sine of x, right, and I graph that on my thing here. Graph that, and I have the graph of y equals the cosine of x minus pi over 2. Did that work out? Oh my gosh. Not at all, huh? Pi over 2. Get there, buddy. Alright, it's not working out. He's all upset at me. Go slower. Pi divided by 2. Are you happy now? Yeah, there you go. There you go. And I graphed that one on there. Check it out. Oh my god, they're the same graph. Exactly. They are both there. Why is this? Anybody have any thoughts as to why that could be? Yeah.
Because when you do it minus pi over 2, you're shifting it.
That's exactly right. Okay, remember that pi over 2 is 90 degrees, so sine and cosine are co-functions. So the sine of something has to be the same thing as the cosine of 90 minus that something, right? So you end up with the same graph. That's why you could have two different graphs that represent the same thing. One could be sine, one could be cosine, but obviously, looking at these two, the sine function's easier looking because there's no phase shift going on. Do you guys understand that part? So when we're dealing with this part, there really could be two graphs, right? You could have a sine or a cosine, but one is more obvious than the other. And I'm asking you guys, do you have any inclination as to which one you think is more obvious than the other? Okay, yeah, say sine. Now, why do you say sine? Because it starts at the origin. So there you go. So that's our first thing we got to do is we have to figure out, I'm going to call this a sine function. So I'm going to build my function. This is the sine of x. Then I'm going to implement my 5 dots. One goes there, one goes there, one goes there, and one goes there. Those are my 5 dots that I always deal with for sine function. Then I ask myself, is there an amplitude that I need to consider? The amplitude is still 1, so that doesn't change my equation, right? Y equals sine of x. Then I have to ask myself, okay, is there a period going on? And yes, there is, right? Check it out. All of this is one period. So one period is equal to a distance of 4 pi. That's period. Can't you tell? 1 period is equal to a distance of 4 pi. But 4 pi is not the number that we were getting all up in here, right? That's not the number that goes in the equations. So my question is, how do you figure out what goes right there in between the sine and the x? Yes?
Divide that by 2 pi.
You got it. So here's what you do. You take 2 pi divided by something. I don't know what it is. It's a question mark. But it has to equal 4 pi. So 2 pi divided by what gives you 4 pi?
Isn't that the same thing as 4 pi divided by 2 pi?
No, it's not.
Yeah. 'Cause then
You get 2. Yeah. So 2 pi divided by what gives you 4 pi? 1/2. So the thing that goes in my equation is the 1/2. So my final answer for this thing should be y equals the sine of 1/2 x. So that's the equation that matches this curve. You guys with me on that? I don't think you guys are sold yet. Okay, take out your calculators. Let's go. Let me show you. Okay. Turn your calculator on. Go to y equals. And, oh, look, I already have this one here. Okay. What we're going to do is we're going to punch in the sine of 1/2 x, and I used 0.5x in my calculator to do that. But I need to change the window, don't I, in order to make it match my screen perfectly. So I'm going to go to the window function. And I'm going to start when x is 0. I'm going to end when x is equal to what? What's my picture say? 4 pi. So punch in a 4 pi there. So 4 second pi. And then when you move off, it changes it to 12.56. What's the scale I'm using? What are the increments of my x value? Pi over 2. So second pi divided by 2. Boom. There you go. My lowest y value.
-1.
Yeah, I'm going to go down to -2 just to give myself some, actually -5 on the picture, true. And then I'll go up 2. So now when I hit graph, the thing on my calculator should be exactly the thing on my screen. And it is, right? So every pi over 2, pi over 2, 2 pi over 2, 3 pi over 2, so pi, right? There's a 0 there. So at 2 pi, there's a 0 there. I go all the way out to 4 pi, there's another 0. So I've matched, I can check to make sure I did it right. You guys with me? Okay, let's go on the next one here. Ooh, look at this awesome graph. All right. So together as a class, what do you think? Is this going to be a sine curve, or is this going to be a cosine curve? You guys say sine? Yeah? Andrew, you say sine? Yeah? Say yawn. So tired? Okay. Yeah, so sine curve, right? So here's my 5 dots. 1, 2, 3, 4, and then 5. So I'm going to start off by saying this must be a sine curve. All right. Then I'm going to consider my amplitude. How high up do I go, and how far down do I go? So where does the 3 go? 3 sine of x. Good. Now I need to consider the period. If I start here, I go up, and I go back down, and then I go to here. How long is that? What's the distance? Pi. So I ask myself, okay, 2 pi divided by something has to be a period of pi. What does the something have to be? The something has to be a 2. That's what goes into my equation. So my final answer should be y equals 3 sine 2x. Isn't this cool? You've never been able to do this before, right? We'll look at an actual trig function and decipher what the heck's going on there, amplitude and period-wise. Next one. Ooh, curveball. Throwing a curveball at you. Ooh. All right, what do you guys think? You guys going for sine or for cosine? Cosine. Okay, why do you say cosine? Because it doesn't start at 0. So we got a dot there, a dot there, a dot there, a dot there, and then a dot there. But there's something else going on. So we're going to start by, okay, we think it's a cosine, okay. But what has been happening to, yeah, it says a reflection, so that gives me a negative cosine x. Any amplitudes to consider? Yeah, I've gone up a distance of 2 and down a distance of 2 from my center line. So that means I have the equation -2 cosine x. Now, is there a period to consider? Well, yes, there is. Look at how long this takes. How long does that take me? It takes me 6 pi to do that. So I take 2 pi divided by something has to give me 6 pi for my answer. So Oh man, you guys are so smart. So the something must be a third. So my final answer is y equals negative 2 cosine 1/3 x. Dude, how awesome is that? That you guys can do that now. That's pretty sweet. You can just look at a trig function and go, oh yeah, I know what that is. Oh yeah, I know what that is. I'm impressed. Very impressed. Okay. Ooh, las fracciones. Okay. First of all, do you guys decide, is this a sine curve or a cosine curve? This is a sine curve, yes. Y equals sine of x. Now count out your 5 dots. There's the 1. There's 1, 3, 4, 5. That's what you're looking at, okay? So you're looking at this period right here. All right, good. Now, is it purely a sine curve or has it been reflected? It's been reflected. So let's create a negative sine x. Now consider the amplitude. From the center line to the top, from the center line to the bottom is how many units? 5 units. Where does it go? Negative 5 sine x. Good. Now consider the period, which happens to be pi over 2. So we take 2 pi, the normal period for a sine curve, divide it by something, and it has to give me a period of pi over 2. What does that thing have to be?
4.
That thing has to be a 4. So y equals negative 5 times the sine of 4x should be your final answer for that trig function. Did you get it? Why did I stop at pi over 2? Because that's one complete cycle. Well, I mean, yeah, I could keep going at that, right? It's just, that's more than one full cycle. Huh? It's just because the graph goes on forever in both directions, but I'm only concerned with one cycle to get all the information that I need. See, this equation here will produce that entire graph for an infinite amount of x variable, you know. Because if it was positive, then this graph would be reversed. It would be reflected up. You know what I mean? You follow me? Here, let's do this. Let's play. Check it out. What was it? It was y equals... Let's do 5 sine... was it 4x? Okay, do I have that all down there? Okay, good. So if I draw that graph, notice how it goes on and on forever and ever, right? So I'm only looking at a specific range of it. I only want like a little bit. I don't need all this stuff going on. You know what I mean? So I can, zoom in on this thing and get the piece that I want to get out of it. Now, if I make this a negative sign, watch what happens to the graph. It just flips over on itself. So that's what the negative sign does. You with me? Kind of? Yeah.
With the normal sign, it goes up first. With the negative one, it goes down first.
Yeah, that's exactly right. Yeah. So with just regular sine of x, right? Okay. We have normal, that's our normal regular old sine curve. When I have the negative out in front of it, it makes it, gives me a reflection over the x-axis. That gives me the blue curve. So it basically just flips it over on itself. You got it now? All right, cool.